So for question 11a, it says find the equations that will model each of the following. So the equation for the simplified transform function is y equals abx plus c. So some things I'm noticing is that one, my c value should equal to 0 because I'm noticing that the horizontal asymptote is occurring at y equals 0. So my second piece of information is that my y-intercept is equal to 0, 12. So based on this information, I can conclude that the distance from my y-intercept to my horizontal asymptote is a value of 12, and therefore I can conclude A is equal to 12. After that fact, it's a matter of algebraic work, okay? So you basically have an equation where the A value is a 12, the base value you don't know yet, and then you have a C value of 0. So when you have this kind of equation, you're noticing that, well, I don't know the B value, but I do have a graph, and I know a bunch of coordinates. And so you're simply going to pick any coordinate, so sub a point like 3, 6.14, you're going to plug that in and see what you get. And so I'm going to have as a next line, 6.14 is equal to 12, bracket B, and my x value is equal to 3. I'm going to work algebraically backwards, so BEDMAS backwards to try to get B by itself. So my first step is to divide by 12 on both sides. And then B is equal to, well, B3 is equal to that value, which is about 0.512. After that point, I have, well, I want to cube root both sides so that I get B is equal to 0.8. Meanwhile, well, if I have my A value, I had just found my B value, and then I had my C value from the beginning, I can conclude, therefore, y is equal to 12, bracket 0.8. The exponent x, well, plus 0, that does and doesn't really have to be there, and that is my equation. So for question D, I'm noticing that first off, my graph is trying to approach a value of horizontal asymptote at y equals 3. Based on that fact, my C value is equal to 3. My graph has basically shifted up 3. So what I have so far is y is equal to ab to the exponent x plus 3. At this point, you're going to try to figure out your values. So in this case, we have two variables, two unknowns by the time I sub in a coordinate. So what I mean is, first I'm going to sub in a single coordinate like 3, 1.8. When I do that, I will get 1.8 equals a, b to the exponent 3 plus 3. At that point, I'm going to try to get my a and the b together. And so I'm going to subtract 3 to both sides, and I'm going to get ab to the exponent 3 is equal to negative 1.2. That is my first equation. At this point, I need to have two equations because, again, when I have two unknowns, I need to have two equations to solve for it. So at this point, I'm going to sub in another coordinate to the original equation, which is y equals ab to the exponent x plus 3. So I'm going to sub, let's say, 2, negative 3. And so you're going to get negative 3 equals ab squared plus 3. Again, I'm going to try to get a and the b by itself. Subtract 3 to both sides, and I get ab squared is equal to negative 6. At this point, you're going to try to combine these equations. Combine it so that you have a single related equation to work from. So that should remind you of the previous unit. And so at this point, when I divide the two, I am going to get, well, negative 1.2 divided by negative 6 is equal to AB3 divided by AB2. These parts are going to cancel.
So I use one method of elimination to get to this answer, but keep in mind I could have used a different substitution or elimination method, and as long as I get b equals 0.2, we should be good.
At this point, you have one of the variables, so you just simply need to plug it into either equation 1 or equation 2 to try to get the a value. So I'm going to sub it into a more simpler equation, which is my equation 2. So I'm going to sub 0.2 into 2, and I get -6 is equal to a bracket 0.2 squared. 0.2 squared is equal to 0.04, so I'm going to divide both sides by 0.04, and I get a is equal to -150. Therefore, I get y equals -150 bracket 0.2 x plus 3. Okay, so for question B, I'm given a table of values at this point and trying to make some observation, and I notice that the y-intercept is 0, 84. So meanwhile, I am noticing that the horizontal asymptote is y equals 0. And based on this fact, that means that the distance between my horizontal asymptote to the y-intercept is going to have a distance of 84. Therefore, I'm going to conclude that my a value is equal to 84 due to the distance
Between the horizontal asymptote of y equals 0 to the y-intercept of 84.
So So next, you might calculate the first difference in your head between these y values. And then you would realize that it's not exactly a first difference or second difference case. So next, you're going to try to calculate the first ratio. And so I'm doing 2.625 divided by 5.25. And as I do this, I'm getting 0.5 consistently every time when I do next y divided by original previous y. And so based on this, I can conclude that b is equal to 0.5. Meanwhile, I know that since my horizontal asymptote is at y equals 0, that means there was no shift up or down. Therefore, my c value is equal to 0. Therefore, I can state my simplified exponential equation by writing y equals 84, because that's my a value. I have my b value of 0.5 with the exponent x, and my c value of 0. Next, for question C, I'm noticing that first off, my horizontal asymptote is approximately at y is equal to 4. I'm noticing that my graph is trying to get to 4, but it's never going to reach 4. Because my horizontal asymptote is at y equals 4, that means my C is equal to 4 because there's been a shift up of 4. Next, I'm going to try to find my a value. So again, my a value is not just my y-intercept. That's not what a value is, although sometimes it might look like it. I'm noticing my y-intercept is 0, 1. Remember, the a value is the distance from your y-intercept to the horizontal asymptote. And so the distance between those is a is going to equal to -3. Why is it -3 and not just 3? It's negative since y-intercept is below the horizontal asymptote right here instead of it being above it. That means that there was a reflection along the x-axis. Meanwhile, so I can start writing my equation, which is y equals abx plus c. I'm going to start to input what I know. So I'm going to write y equals -3. I don't know my b value with an exponent x. I know my c value is 4. Keep going. I am going to now sub in a coordinate. So any of the coordinate would be okay. So I'm going to sub in 1, -2. So that is my x and y. When I sub it in, I'm going to get -2 equals -3b to the exponent 1 plus 4. I want to get b by itself by doing BEDMAS backwards. I'm going to subtract 4 to both sides, and I'm going to get -6 is equal to -3b. I want to get b by itself, so I'm going to divide both sides by -3, and so b is equal to not negative 2, but positive 2. At this point, with all the information I have, which is my A, my B, my C, I'm going to conclude my transformed simplified equation, which is going to equal to y equals my A value of negative 3 due to that reflection. And then I have my base of 2 to the exponent x plus 4. So now for question E. So something that you might know do right away is that, well, the horizontal asymptote is at y equals 2, so it's given. So I can say that C is equal to 2 as the very first part. One thing you might try to do is try to find the first ratio given the table of values.
So keep in mind that the first ratio will equal the b value if and only if the x values are going up by 1. And in this case, it's not. And although I'm showing this work of calculating my first ratio, I should really go through things algebraically to confirm.
So I have y equals a, b, x, and meanwhile the c value is 2. So based on this, I'm going to start plugging in some coordinates because we're given a bunch of coordinates according to our table values. So I'm going to sub in point 3 comma, let's say 17.5. And for now, I'm going to use a rounded value. And so I get 17.5 is equal to, I don't know my A, I don't know my B, but I know my X is 3 and plus 2. And meanwhile, I want to get the A and the B by itself, so I'm going to subtract 2 to both sides, and I get AB to the exponent 3 is equal to 15.5. Next, if you notice, I have this equation 1, but again, I have two variables. That means I need to introduce a second equation. So I'm going to sub in another point, let's say 6 comma 71.6. So I'm using another rounded coordinate for now. And when I plug it in, I get 71.6 is equal to AB to the exponent 6 plus 2. I want to get the AB values by itself. And so I'm going to get AB to the exponent 6 is equal to 69.6. Okay, so remember, you can use substitution or elimination to try to combine these equations and create a related equation, right? But with these, when I have a monomial like this, it's going to be the easiest if I divide these two equations and try to combine it that way. And so I'm going to get AB6 divided by AB3 is equal to 69.6 divided by 15.5. That's going to get the A's to eliminate, and now I have a B3. And so I have B3 is equal to 4.49 approximately. I'm not done yet. I need to get B by itself. And I'm going to cube root that on both sides to get the B by itself. And B is equal to 1.65. At this point, I'm going to sub B into either of these two equations is fine. I'll sub it into 1 because it looks a little easier. And so I get 15.5 is equal to A bracket 1.65 cubed. I want to get that A by itself. So I'm going to divide both sides by 1.65 cubed. And that's going to get these two values to cancel out. And I'm going to get A is equal to approximately 3.45. So when we conclude all the three highlights, I'm going to get, therefore, y is equal to 3.45 bracket, my base is 1.65 with an exponent x, and my graph has moved up to
Units up, and therefore, this is my final transform simplified equation.